Okay, quick review of what we did last time. We have a method here called keep, and it's going to take an array of data or an array list of data, and then we're going to have a method that we're going to pass on to it. And this method is going to give us a true or false when we call its test method. So this test method of our predicate, if an item comes true, we'll add it to our result list. Otherwise, we throw it away. And then what we can do is we can now keep the numbers and then we pass on the method. This method doesn't have a name. It just has the parameter list, an arrow, and then the body of the method in braces. There is a way to make that even shorter. So there are several shortcuts that you can do to make it even more compact, but I'm not going to go into them unless somebody wants to find out about it. Ask me later, and I'll look it up myself. Okay, actually, yeah, a little bit better yet. Let's go here and see if I can find where this is. What am I looking for? Called tutorial functional. I think this is it here. Okay. Shoot. Arc. Let's see if that, there we go. Yes, there's a tutorial on it here. And I'll put that in the notes for the announcement when I put up the lecture, okay? So yeah, this will show you ways of doing it that are incredibly compact. If you want to know everything there is to know about it, that's where it is. Yeah. So at any rate, here we had one method, and this one we've defined it inline. Now, if your predicate gets sort of complicated, if there's a lot of lines to it, you can make it a separate predicate. And again, it has the same thing, namely the parameters, an arrow, and then the method body, and you assign it to a variable of type predicate. And then I can use this name that I've given it instead of having to put the method right into the middle of that other call. Okay, well, this is all very well and good if all we're going to be doing is talking about predicates and we want to filter things out. But functional programming like this, higher order functions, let us do more interesting stuff as well. One of the things that we would often like to do is we'd like to take one list of numbers and then transform it. So for example, I might want to take this list of integers and I might want to get another list that has the square roots of all those integers as doubles, because they'd have to be a double so we get the decimal points. Or I might want to have a list of strings, and then I want to take that and convert it into a list that gives the lengths of each of the strings. And that's called mapping. Now, that has nothing to do with a hash map. Unfortunately, it's called map as in like a function. They map the domain to the codomain. Do you remember that from your algebra? Okay, that's what we mean when we say a map here. So we're taking one list and we're mapping it into another list. And here's our generic function that will do it. We're going to take some array list of data with one data type, and then we're going to apply a function to it that takes that data type and returns a different data type, possibly different. They could return the same data type. There's no law against that. And then it will return to us an array list of our result type. So you can think of T as our input type and R as our result type. We'll create a new array list for our result. And then for each item in the data, we're going to take whatever function you give us and call its apply method on that item. And then we'll add that to our result and return the result. So here's this one. I have 16, 44, 25, and 22, and that's going to be numbers. I want an array list of double called roots, and I'm going to map the numbers using this function. So every element in the list will have this function applied to it. Namely, it'll return the square root of the absolute value of that number. Now, again, here I've put the lambda, the anonymous function, inside the call. I didn't have to create a variable for it. If I do have a complicated method that's going to be the function that I'm applying, I can make it a separate one, just like I made a separate predicate. I can say, here's a function that takes strings and returns an integer, and this is its anonymous version, namely take a string and return the length. And then I'm going to give it a name, and then I'll take this words array list and map it, applying strling to each one of those, and that'll give me an array list of integers. And sure enough, that's what I get. So again, that is the function interface. So for things that return a Boolean, we have the predicate interface. When I want something that takes a parameter and gives me back a result of the same or different type, then I need to use something called a function. Now let's apply the, no pun intended, let's apply this with our Newton's method. Remember that one that we did earlier here where we were trying to find x squared minus n is equal to 0? Yeah. I'm going to get rid of some of this other stuff here. Yeah. So here we want to find the square root, and we have the double n and approximation, and it's calling itself. Now, what I'd like to be able to do is find the root of any equation in general. So what I'm going to do is I'm going to say, let's find the root. Here's our current, here's the, in this case, we're going to have, let's see, am I going to need n here? No, I am not. I'm going to have my approximation, and then I'm also going to have a function that takes a double let me just check to make sure I'm doing this right here. I want to look back at this one. Yeah. I'm still going to do here. This function that we're now going to do is we're going to check it. So all of this stuff is going to have to change, isn't it? Okay. Current approximation and a function f that evaluates in fact, I probably want a better name for it. Remember how we have to have f divided by f prime? Yeah. So let's call this thing f over f prime. Yeah, I know I misspelled it. Yeah. Calculate the next approximation based on the current one, calculate the absolute value of the difference, and so on. So now here what we're going to do is instead of doing this, which is only good for square roots, right? We're going to say our next approximation is going to be f over f prime of the approximation. And now we can pass in a function that will do what we want. Does this sort of make sense here? I have to pause here for a moment because I'm not sure if I'm going to need that n or not. No, I won't. Okay. And this is also going to have to be called find root, I guess. And we're going to have to pass on the f over f prime because we have to pass that function on to the next one. Otherwise the recursion isn't going to work. Now what we can do here is we can have, let's say double square root of 2 is going to be, I want to find the root. And my first approximation will just use a 1 as the square root of 2. That's my first approximation. And now my f over f prime is going to be a function that has a double called x. And the way it's going to work, it's going to take x squared minus 2, right, because that's my function that I'm trying to find the root of, divided by 2.0 times x. And it has to return that. I have not tried this out before. I'm just doing this without a net. So we're going to see if this works. This is going to be very exciting. Now let's compile this and see how many errors I have. Oh, line 51.
Parentheses.
Thank you.
I think after, isn't it?
Yeah, you're right. And also I'm going to need a semicolon, ain't I?
Yeah.
Yeah, okay. Okay, it's always going to be one of those days. Okay. And find root n is not a functional interface. Well, this is exciting. Hmm. Takes only one thing. Let's try that. Okay. Wow, this is getting more and more exciting now. Let's see. Oh, yeah, I see why. Gee, wouldn't it be nice if I were to include that? Let's see if that makes a difference. Okay. Wrong number of types. Requires 2 of them. Okay, so yeah, it was double comma double. I'm sorry. And finally, we have here
Find root uppercase, lowercase.
pardon?
Isn't find root uppercase, lowercase inconsistent?
Yes, that would certainly help. I don't think that's going to solve all my problems, but that certainly isn't going to hurt. F over F prime cannot find symbol. That's really weird. Oh, that's why. I have to call the apply method that begins. There we go. Finally. Okay. See, this is what happens if you don't rehearse stuff. Okay, let's see. And sure enough, it got the square root of 2 correct. Yay, finally. Okay. And now that we have this, I can also do something. Let's say I want to find x squared minus 4x plus 7 equals 0. So I want to find the root of that. And I don't even know if it's solvable or not. You know what? Let me do something that I know is solvable. How about that? Okay. Let's try x squared minus 12 x plus 35 equals 0. There we go. And so now what we need to do here is we're going to say double polynomial root. I'm going to do find root. I'll start with 1 again as my initial guess. And now I'm going to have a method. And that is going to return x squared minus 12 times x plus 35 divided by, that would be 2x minus 12, correct? That's the derivative of x squared minus 12x plus 35. Yes? 2x minus 12. Yeah, I'm pretty sure that's correct. Okay. And just to make sure that everything is double, I'm going to put the 0.0 in there. And then I need to close that and close the parentheses. And then the positive root is indeed 5. Okay, plus the error that you get from doing floating point arithmetic. But the idea is now that I have these higher order functions, I now have a generalized root finding method that will find the root. And as long as I can give you a function that will evaluate f over f prime, then it will go through the Newton's method and I don't have to duplicate the code. So higher order functions let me do this. This is not the same as map, by the way. Okay, I'm not doing a mapping here, but I'm using the function interface to do what I want. Okay, now in addition to mapping, there's yet another operation that's very, very common. Namely, what happens if I have a list of numbers and I want to create one number out of it? For example, the sum of all the items, or if I want the product of all the items. Then that's called reducing. I'm taking a list and reducing it to a single item. And for that, we're going to need something called a bifunction. And what a bifunction does is it takes one item of type R, another of type T, and in the generic case, by the way, it can return yet a third type of item. Okay, so I could have something that takes integers and strings and returns doubles for some unknown reason. Okay, I have no idea why you would ever have a function like that, but you could. So in theory, you could have 3 completely different types of variables. So we're okay. I need to write some commentary here. Okay, so bifunction is a functional interface that has a method called apply. The apply method takes 2 parameters. That's why it's called bifunction instead of just regular old function, okay, of type T and R, and returns a result of type U. That way, all the types can be different, but they don't need to be. And in this case, what I'm doing is I'm going to take a list of integers, and here I'm going to call integer, integer, integer. I'm going to have reduced sum. So I'm going to take an integer result, and I'm going to accumulate it inside of an integer n. And I'm going to add whatever n is to my current result and then return that. And for reducing a product, what I do is I take my current result and the current item, and I'm going to return the result times the current item. So here I'm going to reduce, I'm going to take the numbers array list. I'm going to start with an initial result of 0, and I'm going to call this reduce sum. And now let's see what happens here. What I'm doing, for each item in the data, I'm going to apply whatever method I'm using, namely adding to the result, with the current accumulated result and the item that I have in mind. And what I should do is put some extra output in here. And here I'm going to do another reduce where I'm going to take the numbers. My initial accumulated value is going to be 1 because I start with 0. 0 times anything is 0, and I won't get a good result. And instead, I'll say reduce product. So it'll go through each item in my array list, and it will apply this method here. Give it the current result an item, and it'll multiply n times that item. So those are the two main operations that you do with functional programming. Are the map function, where I transform a data collection from one form to another, and reduce, which is where I take an array list of data and reduce it to a single number. And I'll add one more thing, in fact, on this functional reduce. Let's give one more example here. For example, what if I wanted the sum of squares? And let's call this sum of squares. And that's going to be, I'm going to take my current result and the current item, and I will give you back the result plus n times n. I don't have, I'm wondering if I needed any more parentheses, but no, I don't. And then here, I'll say squared is reduce. My original is going to be 0, and the function I'm going to use is sum of squares. And let's check that out. 1 plus 25 is 26, plus 4 is 30, plus 9 is 39, plus 16 is 55. So we came up with the right answer. Yeah. But this is the idea behind higher order functions. They let you have one method here that takes a function as one of its parameters. And that way you don't have to duplicate the code every time you want to get evaluate a different function. You just pass the function in and boom, it just does it for you. This, by the way, is not going to appear on the midterm or the final. And the reason it's not going to appear on either one of those is because I didn't have you do any exercises on it. So there's no assignment that involves it. But I felt it was an important enough topic to cover. And again, it works very nicely with recursion. So there's going to be a lot of lab time today. Now, one thing that people were asking me about was on this recursion, they didn't quite get this business with the permutation method. Okay. And so what we're going to do is I'm going to try and do this on the board. This is going to be interesting. I don't know if I can get this to work. Boy, today is totally improvised. I thought I had everything all in order when I started off because I had all the files there, but ooh, that didn't turn out too well. Okay. So let's stop the screen sharing. Let's turn on the video. So this says use a loop. To move a character from S2 to S1. And call it recursively. And so the first call that I'm going to make is, let's call it permute. I'm going to give it this empty string. And let's do ABC just so we can see how this is working. Okay. So in the first thing I'm going to do is I'm going to take A and move the character from S2 to S1 and call it recursively. So that means I'm going to say, now I'm going to do a permutation of A and whatever's left over. So when I move it, I'm really removing it from one string and putting it in the other. Now I'm going to take a loop and I'm going to start with this one in B and C. I'm going to move B into there, which is AB. And then I have C. Then I'm going to call it recursively again, which gives me ABC and the empty string. And now that I have the empty string, I can print it out. That's my base case. When S2 becomes empty, I'm finished. Now what I'm going to do is I'm going to back up to here. There's nothing more for me to do in this case, correct? And remember here, I'm doing a loop. So now I'm back. Eventually, I'm going to get back to this point here. And now my loop continues. I'm going to put the C in here. So now I'm going to have permutations of AC and B will be left over. I call it recursively again, which gives me A, C, and B and the empty string. And then I print that out because I've hit my base case. I come here, there's nothing further in the loop. Loop is done. I'm done with this. Now I've come here, go to the loop. Oh, I've finished doing C. So now I come back here and my loop is now going to go to here. So I'm going to do my permute of B, and what's left over is AC. Are you beginning to figure out how this is why it works? Well, okay, fine. That means I'm going to stop writing this call here. That means I'm going to have BA with C, which gives me BAC and the empty string. Oh, good. I'm at my base case. That means I move back here. The loop finishes there. Now I have to go for my loop. I have BC with A left over. And that gives me BCA when I run that loop and the empty string. And so my loop gets on hold every time I do these recursive calls. Come back here. There's nothing more in this loop because I've finished all the letters in S2. And I finished all the letters here. And now I pick up my loop here, which gives me C and AB. Okay. That gives me C, A, and B. That gives me CAB. And the empty string. Pop back up here. B is the next thing that needs to be processed. That gives me CB with A left over. That gives me CBA and the empty string. And there are all my permutations. So that's what's actually happening. I recommend that you do this by hand yourselves so you can see what's going on. Does that help explain why this algorithm is what it is? And that, in fact, is why we wrote this, okay? Because that gives you that's the whole shooting match right there. So I'm going to give you time to work on lab here today. So lots of lab time. And the other thing, on Monday next week, I'm going to do a brief overview of what's going to be on the midterm. And I'm also going to post the topics for the midterm. Probably I might have time to do it on Friday. And there's also a program that goes with the second midterm. And let me give this some thought. If I can find a sample program for you to do that looks a lot like the one on the midterm, I'll put one up, okay? Can't promise that I'll be able to do it, but I'll look at it and see if there's something that I can manage on that. Any questions at this point? And then lab time, I guess. I'm going to stop the recording at this point. Professor, do you have any questions or comments?
No, thank you. I
Okay.
never knew about the filter, map, and reduce in Java. It's very common in Python, but I never knew about it.
Yeah, yeah. As I said the last time, I'd had no idea this stuff had been around since Java 8.
I've heard a stream, but it's but I've used that before.
Oh yeah, that's right. Stream does have map and filter, doesn't it?
That's right, but that's what
Yeah.
usually is used. But what you show is very useful. Very good. Thank you.
Yeah.